All right. So we are going to discuss index and logarithm today, or indices and logarithms. We are going to look at the rules of indices first. Then we'll do logarithms, and then we'll solve a few questions based on these two concepts. Okay. So first, let's get started with laws of indices. Okay. I'm pretty sure all of you have done this in school and even at college level, so you're pretty familiar with this. So the first thing is, let's say if you have a raised to m into say a raised to n. Okay, if you have this, then it essentially means that you can write this as a raised to m plus n. So for example, 2 raised to 3 into 2 raised to 4 is nothing but 2 raised to 7. Right. The second rule is, so there's no order to these rules. I'm just saying that this is second rule, but there's no definite order. Okay. So multiplication means essentially addition of the powers that are there. Okay, but the base has to be same. So a raised to m divided by a raised to n. If that's the case, in division you will subtract. So it will become a raised to m minus n. So for example, say 2 raised to 5 divided by 2 raised to 2 is nothing but 2 cube. Okay, which is essentially 5 minus 2. Right? Let's come to the next rule. A raised to m, this thing raised to n. So it means that you have a raised to m and you're multiplying the same thing n times. So this means a raised to mn. So this is different from a raised to m raised to n, where you have m raised to n as a power of a, and a raised to m, the whole thing raised to n is different from it. So for example, let's say you have 2 raised to 3 and raised to 2, right? So this becomes 2 raised to 6 because it is 3 into 2. Now, you can also look at this as 2 cube 8. So 8 square, which is nothing but 64, which is also 2 raised to 6. Okay. Then anything raised to 0 is 1. So a raised to 0, let's say, is 1. Anything raised to 0 will give you 1. Anything raised to 1 will give you the same number. So a raised to 1, or so in this case, for example, say 10 raised to 0 is 1. Let's say 4 raised to 1 is nothing but 4. So anything raised to the first power is 4. Look at the next rule, a raised to minus m. So if you have, say, negative power, this, if you want to convert it to positive power, you'll have to take 1 upon a raised to n. Right? So a raised to minus n is 1 upon a raised to n. So for example, 5 raised to minus 1 is nothing but 1 upon 5. Okay. Coming to the next rule, which is about square root or nth root. So if you take, let's say, nth root of a number, so let's say nth root of a is nothing but a raised to 1 upon n. Okay? So a raised to 1 upon n. For example, let's say if you're taking square root of 4, this can be written as 4 raised to 1 by 2. All right. Say for example, cube root of 343 will be nothing but 343 raised to 1 by 3, which is nothing but 7. Okay. Coming to the next rule, which is, let's say if you're taking nth root of something and then you have power of a number inside the root sign. Okay. For example, if you have nth root of, let's say, a raised to n. In this case, the part which you did for the root remains the same. So a, this goes to 1 upon n, but you have mth power raised to m now. So you will do m upon n. Okay. For example, let's say if you have 64 raised to, say, 4 by 3. Okay. So this 64 raised to 4 by 3 can be written as cube root of 64 raised to 4 and vice versa. Okay. Then coming to the next rule, in case you have product of two numbers and raised to some power, for example, ab, which is a into b raised to m, this is written as a raised to m into b raised to m. Okay. So let's say, for example, 6 square is nothing but 2 square into 3 square. So 2 raised to 2 into 3 raised to 2. And coming to the last rule, so if you have, so for multiplication we did this, if it is division, it will also apply. So if you have, say, a upon b, this whole thing raised to m is nothing but a raised to m divided by b raised to m. Okay, so for example, if you have, say, 6 upon 2 raised to 3. Okay. So this is nothing but 216 upon 8, which is nothing but 27, which is essentially 3. Okay. So these are your simple rules of indices. Knowing this much is enough to solve all the questions that are based on indices. Okay. So let's do one thing. Let's solve indices questions first, and then we'll come back to the logarithms concept. Okay. Yeah. So let's solve these questions first. Try all four, and then we'll discuss it at one go. So the second question that is there is essentially root 8 raised to 1 by 3. Try the remaining ones as well. Those of you who have answered the first question, try the remaining ones. We'll discuss all of them once you guys are done. All right. So I think all of you have got most of it right. So 256 raised to 5 by 4. So there are two ways in which you can solve this, or even more probably. So 256, if you know that, okay, it is 4 raised to 4, then it's very easy for you to solve. Okay. So one is, what you can do is you can write 256 as power of 4. Okay. So you can write it as 4 raised to 4, and this thing raised to 5 by 4. So this 4 and this 4 will cancel out. So you will essentially get 4 raised to 5, which is nothing but 256 into 4, which is 1024. Okay, so that is one way. The other is to represent it as power of 2, right? So if you know that, okay, 256 is 2 raised to 8, then you can operate from that way, which will essentially it will give you 2 raised to 10 as 1024. So let's say 2 raised to 8 into 5 by 4. So 2 raised to 10, and that gives you 1024. What you can also do is, so this is 256 raised to, so you can write 5 by 4 as mixed fraction. So 1 upon 1 by 4. So this is going to be 256 into 256 raised to 1 by 4, which is nothing but 4. So 256 into 4, 1024. Okay. Second question, root 8 raised to 1 by 3. Again, lot of possibilities. You can write, first of all, root 8 as 2 root 2 if you want to. So 2 root 2 raised to 1 by 3, right? And now you know that, okay, this root 2 is already there. You are supposed to find three numbers when one number which when multiplied thrice will give you 2 root 2. And this 2 is nothing but root 2 into root 2. So that way the answer is going to be root 2. Or what you can do is you can write 8 as 2 raised to 3, and so either you can do this, or you can write, instead of this, say 8 raised to 1 by 2, and this raised to 1 by 3. Right? So this becomes 8 raised to 1 by 6, which is nothing but 2 raised to 3 into 1 by 6. So 2 raised to half, which is root 2. Coming to the third question. So here you have numbers in the denominator. So when you, and those are negative powers. So if you take it in the numerator, it becomes positive. So this becomes 216 raised to 2 by 3, plus you have 256 raised to 3 by 4, and plus you have 32 raised to 1 by 5. So it's a good idea to actually know powers of at least maybe 2, 3, 4, 5 till about the fourth power or the fifth power. And for 2, you can actually remember till 10th power. So 216 raised to 2 by 3. So cube root of 216, that is 6, and 6 square will be 36. So whatever is in the denominator, you will take that much root of the number. So 256, fourth root of 256 will be 4, and 4 cube will give you 64, plus 32. The 2 raised to 5 is 32, so that gives you 2. So total of this is 102. And coming to the last question, here it's simple, a raised to m into a raised to n. So this is going to be 256 raised to 0.25. So 0.25 being 1, 1 by 4. So fourth root of 256 is equal to 4. So pretty straightforward questions. Let's go to the next one. Yeah, again, try all three and then we'll discuss. Yes, most of you got it right except the first question because it's a trick question. So, because you might be tempted to go to the first thing that comes to your mind, which is 11 square, but then there is one more possibility. And because the condition says that they are whole numbers, you can have that condition as well. Right? So, let's discuss the first one. If m and n are whole numbers, such that m raised to n is 121. So, what are possibilities are there? First of all, you can have 11 square. So, that is 121, or you can have 121 raised to 1, which is also 121. So you're getting two cases, first of all. So in the first case, if you have m minus 1, so you're looking at 11 and 2. So 11 minus 1 is 10, 2 plus 1 is 3. So that gives you 30 as the answer. But if you look at the second case, you have 121 minus 1, which is 120, into 1 plus 2, 1 plus 1, 2. So that gives you 240. So there are two possibilities here. So don't be tempted to mark only the first thing that comes to your mind. Coming to second question, which was pretty straightforward. So you know 3 cube is 27 and 3 raised to x plus y is 243. So x plus y is 5 because it is 81 into 3. So x minus y is equal to 3 and x plus y is equal to 5. You're supposed to find x, so we'll eliminate y. 2x is equal to 8, and that gives you x as 4. Okay, simple question. If 6 raised to m is 46656, what is the value of 6 raised to m minus 2? So when you're trying to find 6 raised to m minus 2, basically you have to divide this number 2 more times to get to 6 raised to m minus 2. So you'll have to divide this by 6 once and once again, which is twice, to get the answer. So if you do that, you get the answer as 1296. Okay. So indices questions are pretty simple, except a few questions. For example, the question that we saw, where you might make some mistake. Let's go to logarithms. Now, if you know indices, then understanding logarithms is very easy because, first of all, it's nothing but the way in which it's a different way of writing the laws of indices that we have. So let's look at logarithms now. Now, in logarithms, a lot of people feel that logarithm questions are very difficult in CAT or other entrance exams, and they straight away leave either the entire topic or don't solve those questions at all. So it's not a good idea to do that, first of all, because there are a lot of questions that are pretty straightforward, easy, and only by knowing a few values, a few formulae, you can solve those questions. Okay, so my recommendation is to not leave this chapter at all, even if you may be somebody who finds it difficult at this point of time. But if you practice it maybe twice, thrice, the same concept, formula again and again, you should be able to master it. Okay. So let's start with rules first. Now, before that, let's say you are defining log. Okay. Now, the simplest way I can do it is, we all know that let's say 2 cube is 8. Now, if I want to write this in the form of log, it will be log of 8 to the base 2 is equal to 3. So essentially it is to what number the base should be raised to get this number. Okay, so 2 raised to 3 gives you 8. That's the simplest way in which you can understand log. So if you're somebody who's finding it difficult, at least remember this, that say for example log 100 or log 1000 to the base 10 is 3, which is nothing but 10 raised to 3 as 1000. Okay. So starting with rules, now if you have log of say AB, and I'm not writing base here, I'm keeping base to be same. So if you have log AB, this is nothing but log of A plus log of B. So very simple concept to understand. Let's say if you have log 1000, right? If you have log 1000 and base is 10, you can split this as log 100 plus log 10. Right? Because log 10 to the base 10 is 1, log 100 to the base 10 is 2, and 2 plus 1, this will give you 3 as the answer. So if you have multiplication inside bracket in log, then you can split it as by putting addition sign in between the two logarithms. Now, if you have division, so if you have log of A by B, this you can write as log of A minus log of B. Okay. So, for example, log 10 can be written as log 1000 minus log 100. Okay, so 3 minus 2 equal to 1. Now, if you have some power which is raised, for example, in this case, you have uh, 2 cube, right? So similarly, if you have log 8, this 8 is nothing but 2 raised to 3. So if you write this as, let's say, log of, if you have log of a raised to b, this b will come out of the log. Okay? So this will be b log a. Okay. So for example, if you have log of 8 to the base 2, this you can write as log of 2 to the base 2 and log of 2 cube basically. So this 3 will come outside. You will be left with log 2 to the base 2 and this is nothing but 1. So the answer that we need is 3. So that is one of the rules, that log of any number to the same base is essentially 1. Coming to the next rule, so if you have this, which is nothing but the same rule as rule 3, I'm just using uh, a number which has 1 in the numerator and some number in the denominator. So let's say you have log of 1 upon x raised to a and the base is x. Okay. So this can be written as x raised to minus a. Right? We just looked at laws of indices. 1 upon x raised to a can be written as x raised to minus a. So this minus a will come out and you will have minus a log of x to the base x, and that gives you minus a as the answer. Okay. Coming to the next rule. So log of 1 is 0 because any number raised to 0 is 1. So log of 1 is 0. And log of, let's put it as 6th rule, log of any number to the same base is 1. So log of 5 to the base 5 is 1, and so on. Something that we have already seen and possibly can be looked at as even a law is log of a to the base a and log of a raised to r to the base a is nothing but r, because this r will come out and log of a to the base a is 1. So these will be your basic logarithmic rules. Okay, there are a few more and we'll have a look at those as well. So let's look at the next rule. Okay. Now we have looked till log of a to the base a and so on. Now if you have some number and you have log in the power and that same number is acting as base here, then this is nothing but k. Okay, so log of k to the base b, and this whole thing, if you're raising it to b, then the answer is essentially k. Okay. Then let's look at the next one. So log of, let's say, some number b to the base a. If you take reciprocal of this, you will have 1 upon log of a to the base b. Okay, so 1 upon log a to the base b is nothing but log b to the base a. This is very useful because if you're using some questions where you need to do that, just knowing that you can shift the number and the base by taking reciprocal, that should definitely help you. If you have two numbers, let's say log of b and you have to the base a, and then you have log c to the base b, for example. So when you use the change of base approach, this can be written as log b to some base and log a to some base, right? So you can split the number and the base in this manner as well. And this into log c maybe to some other base or even the same base, and log it will be b to the base x. So this and this will cancel out, which means that finally you can write this whole thing as log of c upon log of b, right? Or in other words, you can also write this as log of c to the base a, right? Because from what we discussed here, which is log of b to the base a, can be written as log of b upon log a, right? Now, the same thing that we discussed, I just want to put it explicitly. If you have log of any number to some base, you can use change of base approach and make it log of b upon log of a. Okay. So for example, if you have log of say 5 to base 2, you can write this as log 5 to some base and log 2 to some base. Okay. One more rule that you can possibly think of is say if you have log of some number and then you have the root of some number. For example, let's say kth root of x, okay, and let's say some base a. Okay. This kth root will go outside because it is essentially x raised to 1 upon k. So it will come out as 1 upon k, and inside you will have log of x to the base k. Okay, so whatever you have as power, that will come outside. Okay, if you have nth root of something, that 1 upon n will come out. Okay. Then there are few values that you will have to remember if you want to solve these questions quickly. So up to from log 2 to log 5 is something that you should remember. Okay. So log 1 is 0, as we discussed. Coming to log 2 is 0.3010. Log 3 is 0.4771. And then some of the values are easy to find. For example, if I want to find log 4, it's going to be nothing but this into 2, right? Because it is log 2 to the power 2, and this 2 will come outside and just multiply 0.3010 with it, right? So that gives you 0.6020. And it's better if you by heart these values straight away so that you don't have to think. And coming to log 5, again, log 5 will be very easy because it's nothing but log 10 upon log, so log 10 minus log 2, right? So log 10 is 1 minus log 2 is 0.3010. So this will give you 0.6990 as the answer. So log 5 is 0.6990. And log 10, as we saw here, is 1. So similarly, you can find other values as well, right? So log 6 is going to be log, the summation of values of log 2 and log 3. Okay. All right, so let's solve a few questions. Now, before that, just wanted to touch upon a few things about logs. One is, the conditions, right? So first of all, the number has to be greater than 0, right? So any number has to be greater than 0 for you to take the log of it. The second thing is that the base should be positive. So base has to be positive and should not be equal to 1. And the last thing is log of negative numbers is not defined. Okay. So again, nobody will sort of be asking you simple questions like these, whether log of negative numbers is defined or not. But you need to remember these things because there might be a few applications at some questions where you don't have to solve, but just by knowing that log of negative numbers is not defined, you can answer the question. The other bit is when you get value of a log, it has two parts. One is the integral part and the other is decimal part, right? So log value will have integral part and the decimal part. So the integral part that you get is called characteristic. So you might see questions where they have mentioned something to do with characteristic of the log. And the decimal part is nothing but mantissa. Okay, so don't get confused with these terms. There's nothing, no rocket science there. Just remember that the integral part is called characteristic and the decimal part is referred to as mantissa. Another thing is if you have any number to base 10, then that is the common logarithm in which we operate. Right? Generally, we'll be using common logarithm for most of the questions. But in case you have ln, which is natural logarithm, just remember what it is. So ln, you will have something like ln x. You may not get questions based on this because in most of the cases, without calculator, you'll not be able to calculate that. But that is defined as log x to the base e, where e is 2.718. And this is called the natural logarithm. So base 10, common logarithm, and base e, natural logarithm. Okay, so this much theory, if you remember, most of it is going to be application. So if you remember the 10 rules that I've listed down, plus the values of log 1 to 5 that I've written here, you should be in a position to answer most of the log-based questions. So let's solve a few questions. I think I have about 10 odd questions, I think, on logs. So let's get started. Okay, I'm just going back because one of you asked me a question. Okay, so we have an example wherein this gets covered, so don't worry. We'll come to that example and I'll explain it. Okay. Okay. So I can see some of you have answered the question. Now, see, the questions are not difficult, so don't be worried in case you're not able to answer it. It's okay. The first thing is when you get a question like this is to represent this because this number ideally will be some power of some number. If it is not, then again you will find ways to handle it. Now 5 and 2 is, and by now you should know that it is 2 raised to 9. So what you have here is log of 5 and 2, and that's to the base 5. So this you can write as, first of all, by using change of base, we are writing this as log 5 and 2 upon log 5. Okay. The next thing is to do, what you can do is this 2 raised to 9, and this is log 5. So this 9 will come out, and now they have already given you value of log 2. So you can use that value straight away. Even log 5, we discussed that it's better to remember that value, but in case you're not able to remember, you can always calculate that. So 9 into log 2. So in the numerator, you have 9 into 0.3010. And then in the denominator, you have log 5. If you know the value, that is 0.6990, good. But otherwise, you can also do 1 minus log 2, right? Because 5 is nothing but 10 divided by 2. So 1 minus log 2 is something you can do. So 9 into 0.3010 upon 0.6990. So if you calculate the answer, I think some of you have given it comes to 3.87 something. So that should be your answer. Okay, so value of log 512 to base 5 will be 3.87. Okay. Now, let's say you have this question and you're not able to figure out all of this. Okay, you don't know what it is, and you have options, fortunately, for this question. So let's say 5 raised to 1 is 5, 5 square is 25, and all of you should at least be able to do something like this in case you're not able to solve the question. 5 cube is 125, and 5 raised to 4 is 625. The value that you have is 5 and 2, and 5 and 2 lies in between 5 raised to 3 and 5 raised to 4. So the answer that you have is also going to be between 3 to 4. So if you have options, say something like 1 point something, 2 point something, 3 point something, and 5 point something, you know that the answer is 3 point something. So you don't have to actually even calculate that it is exactly 3.87. Okay, so this method works in case you have options and you don't know how to solve. Okay. Let's look at next one. Yeah, so first I'll solve the first question so that you can try the second one. You will have these questions that what is the number of digits in 2 raised to 50 and so on. And don't be afraid of these questions, first of all, because they're very easy to solve. The only thing that you need to know is that you need to take log in these questions. Okay. So I'll just give a quick example before this as to how it works actually. So let's say you have log of, say, 3 raised to 5. Okay. And we are supposed to find how many digits are there in 3 raised to 5. Okay. Now, if I take log of this number, I get 5 into log 3, right? Now, log 3, as we know, is 0.4771 and 5 into this. Now, before that, let's answer this first. So 3 raised to 5 is 243. 5 into 0.4771. And if you multiply this, you will essentially get 2.3 something, right? I'm not writing the remaining part, but you get 2.3. So whatever you get as the integral part plus 1. So if you get a perfect integral value, you have to take it that way. So if you had got, say, 2 here, the number of digits in the actual number will be 2. But in this case, what has happened is we have got some 2.3 something. So the moment you get that, you add 1 to the integral part, which gives you 3. And those many digits will be there in the actual number. Okay, you can try this for any of the numbers and you will understand how it works. So in this case, for example, when you have what is the number of digits in 2 raised to 50, the only thing that you have to do is take log of this. So this will be 50 log 2 and just calculate. So 50 log 2 is 0.3010. So if you multiply this, we'll get 15.05. So this 15, we got some decimal part as well. So there's something in mantissa, right? There's characteristic and mantissa. So whatever I get here, I'll add 1 to that, and that will give me number of digits. So there are 16 digits in 2 raised to 50. Okay. Now you can try the second one and let me know the answer. Yes, pretty simple, 29. Now this will be, you need to find number of digits in 3 raised to 60, right? So this is going to be 60 log 3. And if you know the value of log 3, then it's cakewalk for you. It's 60 into 0.4771. And if we multiply this, we'll get 28 point something. So this 28 plus 1, 29. So there will be 29 digits in 3 raised to 60. You can try for a few examples where you can actually find the value and then cross check. but yeah, of course it will give you the right answer. So for example, you can check for smaller numbers, maybe something like 4 raised to 5 or say 2 raised to 13 and so on. Yeah. Try this. Yes, the answer is 0.954. And let's see. Now you can do this in two ways. One is if you already know the value of log 3, then it's very easy for you. If you know that log 3 is 0.4771, then the only thing that you need, you are supposed to find log 9, which is nothing but log of 3 squared. So it's essentially 2 into log 3. So 2 into 0.4771, and that will give you 0.954 as the answer. So this is one way wherein you know log 3 and then you can answer log 9. If you don't know that, what you need to know is you need to find log 9, right? And you are given log 27. Right? So log 27 and log 9, basically I can write this as log 3 raised to 3. And this I can write as log 3 raised to 2. So this comes down to 3 by 2. Right? Now, if I want to find the denominator part, let it be x, and I have 1.431 in the numerator. So my value of x is essentially 1.431 into 2 divided by 3. And if you do this, you will get 0.954 as the answer. Okay. So this is another way of solving, wherein you represent log 27 and log 9 because they both are powers of 3. So you can eliminate log 3, and just the powers will remain. So log 27 upon log 9, even by practice, these intermediate steps, you will not be writing these. Okay. So log 27 upon log 9, you straight away know that it is 3 by 2, and then you can solve. Okay. Let's look at the next one. And in a lot of log questions, the dirtier the problem looks, the easier it is. Okay, so for example, this question, it looks extremely sad. A lot of people will possibly leave it, but then it's a straightforward question. So as I discussed when we discussed laws or rules of logarithms, change of base is very important. It's very useful in most of the cases. You'll find some application of it. So even in this case, and I can see a lot of you have got it right. This log 1 upon log of 60 to the base 3, this I can write as, essentially everything can be written as log of 60 upon log 3 then this will be 1 upon log 60 upon log 4. And of course, while solving, I'll not be writing these intermediate steps that I'm writing. I'm writing it here because I want to explain it to you guys. But otherwise, while actually solving, we won't be writing this. And since it is this, everything that is in the denominator of the denominator will go to numerator, right? So you will have log of 3 plus log of 4 plus log of 5. And then you have a common denominator, which is log 60. Right? And as the first rule that we saw of logarithms, we can multiply this now. So this is nothing but log of 3 into 4 into 5 upon log 60. So this is log 60 upon log 60, hence 1. Okay. Very simple question. Again, intermediate steps are not required. Okay. Again, if you have options, then it becomes even more easier, because possibly for a lot of questions you will have 0, 1, and some or the other thing which you can substitute and then try to find out. But yeah, I mean, options just make life a little more easier. Now, in this question, first of all, how to start something like this in case you're not very comfortable with log questions. The first thing that you'll observe is that everything is to the base 10. Right? So only thing is this 1 here, but you can write this in the form of a number which is, and the base is 10, right? So this 1, I can write this as log of 10 to the base 10, right? The moment you get that, then it's very easy for you, because you have base common across the left side and the right side. Okay? So I can, first thing is I'll write 1 as log 10 to the base 10. And then the next thing is the operator that is there in between. So for both of them, there's a plus operator in between, which means I can multiply the values, the numbers. So this I can write as 5 into yx plus 1 and log of this to the base 10. And that will be equal to x plus 5 into 10. Right? Again, the log to the base 10 part is irrelevant now because they are same. So 5 into 5x plus 1 is x plus 5 into 10. So on simplifying this, I get 25x plus 5 equal to 10x plus 15. Right? So that gives me 15x equal to 45 and x is equal to 3. Okay, if you try substituting values also as x is equal to 3, you will get it right, because this will become 16 into 5, 80, and this will become 8 into 10, 80. Right? So that gives you x is equal to 3. But again, the starting point is making sure that you have the same base across, and then looking at the operator and then turning it into multiplication. Okay, so if you have followed what we have done so far, you should have been actually able to answer the question. But let's see. So log of x to the base root 8 is equal to 3, which is a mixed fraction. So the value of this is 10 upon 3, right? So we have log of x to the base root 8 is equal to 10 by 3, which essentially means that root 8, when I raise this to 10 by 3, I get x, and that is what we are supposed to find. So I'll simplify this first. So root 8 is nothing but, I can write this as 8 raised to 1 by 2. So I have 8 raised to 1 by 2, and outside the bracket I have 10 by 3. After this, I can write 8 as 2 cube. So 2 raised to 3, this raised to 1 by 2, and this thing raised to 10 by 3. Okay. So I can multiply this now. Essentially, I'll be left with 2 raised to 10 by 2, which is 2 raised to 5, that is 32, because this 3 and this 3 will cancel out. Okay. So this is pretty simple question, not very difficult. Of course, if you have some options, then it is possibly might be a little easier for you to work out. But in any case, I mean, even if you solve it, it's not a difficult question. So these questions are possibly the easiest questions that you can get from log, because it's simple application of change of base. So if you have, the first thing is, if you have log 5 to the base 5, there's no need to do anything. The answer is 1 in this case, right? This log 9 to the base 4 can be written as log 9 upon log 4, right? And then you have here log 2 upon log 3, right? Pretty simple. So this log 9, again, you can write it as log 3 square, which becomes 2 log 3. And this log 4 you can write as log of 2 square, which is nothing but 2 log 2. So you have 2 log 3 upon 2 log 2 into log 2 upon log 3. So this will cancel with this, and this 2 will cancel with this log 2. You are left with 1. So Soumya had asked a question in between in the chat window on rule 8. I thought that we'll be able to use rule 8 here, because if the numbers were the same for one of the numbers and base, but that is not the case. So I'll just explain how that rule 8 which I had written works. So if you have something like, say, log 5 to the base 7, and you're multiplying this with say log of 7 to the base 6, the answer of this question will be nothing but log of 5 to the base 6. Because how it works is, if you change base, it becomes log 5 upon log 7 into log 7 upon log 6. Right? So this log 7 will cancel out. You'll be left with log 5 upon log 6. And that is something that you can write as log 5 to the base 6. Okay? So for that to work, this base of one of the number and this number has to be same, because then you can cancel it out. Then this number will remain as it is, and this base will remain as it is. So then it becomes log 5 to the base 6. Okay. Try this. So if you're not able to solve this question in, say, stepwise manner, try putting some values. Okay, in a lot of questions, just by substituting a few values, you might be able to hit the answer. So try putting a few values of x and then see if you can answer. Now, for example, I can't put x as 1 because if I put x is equal to 1, I know I'm going to get log of 5 to the base 2. And then I have log of 20 to the base 2. Again, I can't do anything with that. Right? So choose values of x that will help you get somewhere. Yeah, the best thing is to put x at 0. Right? So if you put x is equal to 0, what do you get? Let's see. The first thing is you have log of 1 upon root 8 and base is 1 upon root 2. So if you multiply 1 upon root 2 into 1 upon root 2 into 1 upon root 2, right, you get 1 upon root 8, right? So answer for this part is 3. Now you need to get 3 from here. As I said, the first thing is to put some value. So let's say if you put x is equal to 0, what do we get? We get log of 2, log of, you have 4 raised to 0, so that is 1 plus 1 to the base 2. So this will give you log 2 to the base 2 and that is equal to 1. Right? And then if you put 0 here, what do you get? You get 0 plus 1, that is 1, and 4 plus 4 is 8. So you have log of 8 to the base 2, that is 3, and 1 into 3 is nothing but 3. And that's why value of x is equal to 3. But let's say you want to solve this. You want to follow the long path that you have to take to solve this. How will you solve? Just by pure observation, you can see that this is 4 raised to x plus 1. And if I multiply this number with 4, let's say I do 4 into 4 raised to x plus 1, what do I get? I get 4 raised to x plus 1 plus 4. So, which is nothing but this part. Okay. So, this whole problem, or the right hand side of the problem, I can write this as log of 4 raised to x plus 1 to the base 2 into log of, so if I take 4 out, I have log of 4 into 4 raised to x plus 1. Okay, so this is what I have, and I can actually calculate this part because I have multiplication inside, which will become addition, right? So this, let's say now log of 4 raised to x plus 1 to the base 2, let's call it k. Okay, so if I simplify this further, I'll get k into, I'll have a log of 4 to the base 2. So I have 2 inside, k into k plus 2, right? Because I have I have k inside as well because it's log of 4 raised to x plus 1 to the base 2. So if I just solve this k into k plus 2, and I know that that is equal to 3, right? Because my left hand side is there. So if I solve this further, I'll get a quadratic equation, and the solution of that would give us x is equal to 0. Okay, so that is the way in which you can solve it. But then if substitution works, you will always go for substitution. Try this. All right. Let's see how to solve this one. Now, as I also said while we were solving one of the questions, that you look for pattern. I mean, you look for some kind of consistency. You have log of root 27, then you have log of root 1000. There's a reason why they have not given this as in the root form, right? But then to make it consistent, you can write it in the root form and then take raised to 1 by 2 out. And that's what we are going to do. So this is log of root 27, and then you have log of 8. But I can write this as log of root 64. Right? Plus I have log of 1000, root 1000. And then in the denominator, we have log of 120. So now we know that it's root across, so I can take it out, right? So I can do it as half. Then I have log 27, log 64, log 1000, and so on. Now, again, 27, 64, 1000, what are these? These are cubes, right? So I can write this as log of 3 raised to 3 into, I can write this as log of 4 raised to 3 into, or sorry, not log inside, 4 raised to 3, and then 10 raised to 3, right? And then I can write log 120 as it is. Are you guys able to hear me? Because there seems to be some internet connection issue. Hello? Yes, okay, fine. Yeah, so we were at log 3 raised to 3 into 4 raised to 3 into 10 raised to 3. And then I have log 120. So again, this 3 will come out because it's the third power of all the numbers. So I have 3 by 2 outside, but I have log of 3 into 4 into 10 inside, and I have log 120. So this is nothing but 3 by 2 into log 120 upon log 120. So this will cancel out. You have 3 by 2, which is nothing but 1.5. Okay, so pretty straightforward question, but the only thing is you need to look for some catch in the question, which will give you the first step that you have to do. Yeah, so that brings us to the end of the session tonight. So we discussed rules of indices, we discussed rules of logarithms, and we solved questions based on indices and logarithms. Okay. So if you guys have any doubts, let me know. Otherwise, I'll see you guys in the next session. Okay. Thank you.